Welcome to Physics Video 3, where we cover something that is actually pretty simple, but is really key to the entirety of physics: the difference between vectors and scalars. Now, I mentioned vectors kind of offhandedly back in Video 1 when we were discussing our 6 fundamental values of physics. And those 6 fundamental values that we covered were length, time, mass, volume, density, and that weird last one, displacement. Now you may have been kind of thrown off when I mentioned displacement, because while all of these have separate ways of measuring them, length is meters, seconds, kilograms, that's centimeters, cubed, and then of course kilograms and centimeters to the -3. Displacement was also meters. I said the only difference between displacement and length is that one's a vector and one's a scalar. What is a vector? Well, it's pretty simple. Displacement here is the only one of these values that has to be coupled with direction. Whenever you are making a value of displacement, whenever you are talking about displacement, you must couple it with its cardinal direction. Let's say your displacement is 3 meters, you must also say it's in the northerly direction if you were moving north, or the southern direction if you were moving south. And that is how vectors work. We use vectors a lot in physics because direction is quite useful in showing things relative to each other. When you're just moving and you don't have a direction, you don't know where you're moving. But once you do, now you know where. And thusly, when we're talking about vectors, we can add them and subtract them like any other value. But it's a bit different. The way we portray a vector is as a line. Let's say, here we go. That's a vector. That is 6 meters east. We're moving east. Let's say we have another vector right here. Let's say that's 3 meters to the north, because it's pointing up to the north. How would you add those? How do you add arrows? Doesn't make sense, Lucas, you tell me. Well, yes, it can, and it does. The way that we do it is we find the resultant. How do you find the resultant, you may ask? Well, it's pretty simple. You draw your first vector, then you draw your second vector with the line starting at the tip of the first vector, going up, and then you draw a line between them, a hypotenuse, and that is your resultant. So here's our 6 to the east, and here's our 3 to the north. But how do you find a hypotenuse, you ask? Did you not take basic math? Pythagorean theorem, a squared plus b squared equals c squared. And thusly, you end up adding 36 and 9 together to get something along the lines of 45, and you take the square root of 45. I'm not going to bother to find that. You get the gist of it. That's how you find your resultant. And that's how you add vectors. Now, how do you subtract them? It's actually a lot simpler than you may think. Let's say we're taking vector A, and we want to subtract vector B to get whatever our resultant is, C. Well, the easiest way to do that is to say vector A plus -B equals C. Why is that the easiest way to do that? Let's use the same two before. The 6 meters to the east and the 3 meters to the north. Well, this is what our 3 meters to the north look like, but in order to subtract, we add the negative. So we flip it around, and now it's 3 meters to the south. Once again, we draw that hypotenuse, and thusly, you have your resultant. And bam! That's really all there is to it. So, that's adding and subtracting vectors. However, there is one last thing that we can do with vectors that we will be doing a lot, and that is taking components. Let's say you have this random line here. It's up in a random direction. It's a vector. Let's call it vector x. Now, sometimes, actually a lot of times, not just sometimes in physics, we don't want to use that diagonal line. We want to take the components. We want to see the part that goes up here and the part that goes horizontally here. Because when you have stuff that's just going vertical or horizontal, it's just easier to calculate with. And so how would you do that? Well, we use those wonderful trigonometric functions, sine, cosine, maybe tangent, but tangent's like the redheaded stepchild. We don't really use tangent. And so what you do is turn this into a right triangle, my friend. And what's here? X is the hypotenuse. And we want to find this here, which would be, to our angle theta here, the adjacent. So we take the cosine of theta equals what we want to find. We'll label it xh for x in the horizontal direction. How about x of x? Because it's on our x-axis. X of x over x. And to find x of x, it's just x cosine theta. It's the same. This line right here is equal to that. So now we just do sine. X sine theta will equal x of y. And it's just that simple. I just did it with variables, so doing it with numbers can't be that much harder, can it? And so that concludes our video on vectors and scalars. Pretty simple, but it is integral to our next section. Get ready, because next time we're jumping into topic 2, mechanics.